All right, let's dive in. Today, we're popping the hood on the tech that is, let's be honest, changing just about everything. Large language models. You know them as LLMs. And look, if you've ever chatted with an AI, you've used one. But how do they actually work? What's going on inside the machine? Let's find out.
And seismic shift is exactly the right way to put it. I mean, that's not an exaggeration at all. This isn't just another little software update we're talking about. No, this is a fundamental, ground-shaking change in how we interact with information, with computers, with everything.
Okay, so to really get a grip on that shift, we first have to understand what this new kind of AI really is. So let's start at the beginning with a clear, simple definition.
Now, what's so important here is the wording. It's not just a program, it's an advanced AI system. And it isn't programmed with a bunch of grammar rules like old software. No, it's trained. It learns by reading massive, and I mean mind-bogglingly massive amounts of text. Books, articles, websites, you name it. It just soaks up all that data and starts to figure out the patterns of how we humans communicate.
So get this. Underneath all that incredible complexity, the core job of an LLM is almost comically simple. It's just a prediction engine. Its whole goal is to guess the next word. You give it New York, and it predicts the next word is probably city. Simple, right? But now, imagine doing that one simple task, billions and billions of times, with an insane amount of nuance and context. That's how you go from just guessing one word to writing an entire coherent essay.
So, how does it get so good at those predictions? Well, that brings us to the engine itself. The big breakthrough, the thing that made all of this possible, is an architecture that came out in 2017 called the transformer.
See, before transformers, we had these things called recurrent neural networks, or RNNs. And you can think of an RNN as reading a sentence like this, one word at a time. It's sequential. And that makes it super slow and really, really hard to scale up. Transformers completely changed the game. They introduced parallel processing, which means they look at the entire sentence all at once. This is just massively faster, and it's what allowed them to be trained on a scale nobody had ever dreamed of before.
But wait, how can it look at a whole sentence at once and not get confused? Well, that's the transformer's superpower. It's a mechanism called self-attention. This is the absolute secret sauce. It's what lets the model figure out the relationships between all the different words, no matter how far apart they are in a sentence.
And this sentence is a perfect example of how it works. I mean, look at it. How do we know what it is referring to? Is it the tree? The drink? Of course not. Self-attention lets the model calculate how relevant every single word is to every other word. It sees it and immediately creates this super strong connection back to tiger because it understands that tigers get thirsty, not trees. It gets the context of the whole thing.
So how does it actually do that? It's basically a three-step dance. First, for every word, the model asks a question. Who else in this sentence is important for understanding me? That's the query. Second, all the other words respond with an answer, or a key, which creates an attention score showing how relevant they are. And finally, the model uses those scores to create a brand new, super context-aware version of each word. It's like every word gets powered up with the meaning of the entire sentence around it.
You know, once researchers figured out this whole self-attention thing, it unlocked the door to making these models massive. And what happened next was, well, it was a straight-up arms race to build bigger and more powerful models.
And the speed of all this has just been breathtaking. Seriously. In 2018, GPT-1 came out and just proved the concept worked. Just 2 years later, GPT-3 comes along, and it's so big, it starts showing what they call emergent abilities. These crazy skills it was never even trained to do. Then, in 2022, the Chinchilla paper comes out and basically changes everyone's strategy. And by 2023, you have models like Gemini that aren't even just about text anymore. And just to give you a sense of that scale, this number, that's the number of parameters in GPT-3. 175 billion. A parameter is basically a little knob the model can tune while it's training to capture some kind of pattern. The leap from GPT-1, which had about 117 million, to this, it was just astronomical.
But then came the plot twist. The Chinchilla paper from DeepMind showed that just making the model bigger and bigger wasn't actually the smartest way to go. It turns out, for the best performance, you didn't just need a bigger engine. You needed a bigger fuel tank to go with it. In other words, the model's size and the amount of training data had to grow together, in balance.
And this table right here tells the whole story. Just look at Chinchilla. It has less than half the parameters of GPT-3, only 70 billion. But, and this is the kicker, look at the training data.
It was trained on more than 4 times as much text. And guess what? This smaller but much more well-fed model ended up outperforming its bigger cousins. It proved that data was just as important as the raw size of the model, maybe even more so.
So the whole industry kind of learned its lesson. It's not just about brute force. To make these models truly useful and powerful, you have to refine them. It's about making them not just bigger, but way smarter, faster, and more aligned with what we humans actually need them to do.
This usually happens in 2 big stages. First, there's pre-training. That's where the model basically reads a huge chunk of the internet to get a really broad knowledge of the world. Think of it like the model is earning a PhD in, well, everything. But then comes the really important part, fine-tuning. This is like its medical residency. It takes all that general knowledge and applies it to a smaller, very specific set of data to become an expert at one particular skill, like being a great chatbot or an amazing coder.
And one of the most important fine-tuning techniques is called reinforcement learning from human feedback, or RLHF. Simply put, this is how we teach the model to be helpful and safe. The model will generate a few different answers, and then a human comes in and ranks them from best to worst. That feedback is then used to reward the model's internal logic, which, over time, gently nudges it to produce answers that are more in line with what we actually want.
Of course, none of this power means anything if it takes 10 minutes to get an answer, right? So a huge amount of work goes into speeding up inference. That's the process of actually generating a response. And there are really 2 main ways to do it. You have methods that approximate the output, which are faster but might have a tiny drop in quality. And then you have these amazing output-preserving methods, like flash attention, that use some really clever math to speed things up with 0 loss in quality.
So all of that innovation brings us to today. And it brings us to the big question. What's next? Where is all this incredible technology going? And what kind of impact is it having on our world right now?
Well, the applications are already just staggering. I mean, they're touching almost every digital industry you can think of. They're acting as co-pilots for software developers. They're breaking down language barriers with instant translation. They're becoming research assistants that can summarize huge documents in seconds. They're basically becoming a new foundational layer of how we work and create.
But the next great leap, the next real frontier, is multimodality. For years, AI was kind of stuck in its own lane. Text models did text, image models did images. But now, models like Gemini are being built from the ground up to understand the world the way we do, as a mix of text and images and audio and video all flowing together. This is a huge step towards a much more comprehensive and genuinely useful AI.
And that leaves us with this final, really critical question. These models are unbelievably powerful engines. They are already reshaping our digital world. So the great challenge ahead for all of us isn't just about building more powerful engines. It's about becoming better drivers. How are we as a society going to learn to steer this technology wisely? That's a question we're all going to have a hand in answering. Thanks for tuning in.